皆さんこんにちは。京都大学から参りました小宮山と申します。今日のこのセッション2のモデレーター自分務めますが、このセッション2ではですね、研究者の方から実務家の方まで、建築にさまざまな立場で関わっている方、日本とヨーロッパそれぞれからいろいろな広がりのあるお話が聞けるかと思います。それぞれの分野で第一人者の方々ばかりなので、そこで若輩の私がモデレーターを務めるのは大変恐縮なのですが、僕自身はですね、去年の10月まで民間の設計事務所で働いていまして、去年の10月から京都大学に移ったという経歴で、いわば実務家と研究者のブリッジをするような役割をもしかしたら期待されているのかと思っています。ちょっと初めに自己紹介を兼ねて、僕が興味のあることを少しだけご紹介しますと、先ほどセッション1の終わりで、シュピア先生の方から、物としての建築とエネルギー、建築材料とエネルギーとですね、そういったものを統一的に考える視点が必要なんじゃないかとかですね、あるいはこうあるべきとかってことを考えるときに、それはどういったシステムだったら成立するのかとか、そういった建築と環境あるいは建築と社会っていうものを統一的に考える視点が大事なんじゃないのかなという問題提起があった気がしますので、その辺をもし可能であればパネルディスカッションで少し話したいなと考えています。僕自身はですね、木造建築の専門でして、木造機っていうのは再生可能な建材で環境負荷が小さいので基本的にはいいものですよね。で例えば今皆さんがここにいるここも随所に木材が使われています。でこれは一昔前、10年ちょっと前であればなかなかこういう大きい建物で木材を使うことは難しかったわけですけれども、増えてきているわけです。それは日本であれば日本は森林資源豊富ですので、林業を活用するという意味でこういったものが促進されてきた部分もあると思うんですけれども、歴史を振り返ってみると実は森が枯渇して資源がなかった時は逆に木造建築が建てられなかったりとかですね、そういった社会的な状況と建築というのが切っても切り離せないわけです。で僕自身はその中でどうやったらそういった社会的状況を超えて、あるいは社会的状況との関係の中で木造建築の普遍的な価値を見出せるかなということで海外に目を向けていまして、例えばイギリスのような必ずしも森林資源が豊富じゃない国ではどう倫理的にあるいは経済的に政治的にどう理由付けがされて木造建築が作られているんだろう、建築と社会がどう関係しているんだろうということを興味を持って実は研究しているのが自分です。でそれは聞いてはですね、建築に携わる人が建築をこう作ろうと思ったから建築がそうなるわけでは必ずしもなくて、建築を依頼してくれる人、作る人、あるいは建築を使う人たちの意識が変わっていくから建築も変わっていくんだと思うんですね。なので今日いろいろなスケールのいろいろな視点からのお話がこれから出てくると思いますので、皆さんはそれを聞いていただいて、ぜひパネルディスカッションの時はご質問いただければと思います。では初めにですね、ワウシスルトンアーキテクツのデイビッドさんから最初のキーノートスピーチをいただきます。どうぞ。
Society Senior Architect, please, floor is yours.
Good afternoon, everybody. Really nice to see so many people return after lunch. I know everybody gets a little bit sleepy, so hopefully this will wake everyone up. I'd just like to say thank you, first of all, for whoever the kind volunteers were. I put quite a lot of text on these slides in the hope that it could be translated into Japanese. I believe it has, so hopefully that will make my slides a little easier to follow. But hopefully we can also have a little bit of debate afterwards. I think it was very relevant to talk initially.
まず最初に話すべきなのは皆さん聞こえますか？
So I think it was very relevant to start by talking about all the other people that have an influence on how we build, because that certainly is a theme of the presentation I'll be giving here. What we're talking about in this second session, I guess, in counterpoint to the first, is the energy that we use to build our buildings, and that has really been a kind of key focus for our practice over the last 10 to 15 years. In the UK, we have very, very strong legislation about the energy that we use during the course of the life of our buildings. So in order to make a real difference now, we felt that we had to focus on the energy that we use to produce the buildings in the first place. I don't want to spoil the surprise, but I guess the way we're dressed and where we're sat gives you a good idea of what kind of material we'll be talking about. We work almost exclusively in timber, so our practice builds are now about 90% of our buildings from mass timber products. And that's been a long journey, and you don't get to the end of that journey without having a lot of conversations, not just with people who care about the planet, but about the people who don't necessarily, for lots of different reasons. People who live in buildings from day to day, people who buy buildings and want to make good profit. And so to become a practice that over 10 years has gone from designing bars and restaurants and quite frivolous projects to important ones that we think have a chance to change the world. It's been quite a long but also very educational journey. A quick overview, I guess, would be to start with Murray Grove, which is the building on the left of your screen, also referred to as Stadthaus. That was what we call the world's first tall timber building. So the product that we work with, that I'll tell you a little bit about, primarily cross-laminated timber, or CLT. Often in Asia it's referred to as MET, so mass-engineered timber as well. That had only been used on projects up to 4 stories before 2009. And in Murray Grove we were able to make a great leap to a 9-story building, to do that for a volume house builder developer, so not for a kind of niche research-led business with a keen interest in sustainability, but just a normal average everyday company. And we'll come back, I think, to why that is really important to us. But then in the middle, you can jump forward nearly 10 years to the building that we recently completed in East London, which is Dalston Lane. And that section of the building there is about the same size as this building, but with an additional story. And the whole of the rest of that building, you can see, is also constructed in cross-laminated timber, everything from the first floor slab above. So you can see that the scale of what counts as a large mass-engineered timber building has changed beyond all recognition in the 10 years in between. And what that's meant is we've also then gone to try and see where else we can go with this idea to build our buildings primarily out of solid wood rather than steel or concrete. And to the right is actually a factory that we've just completed, a furniture manufacturing facility also in England, from laminated veneer lumber, which is a kind of mass timber column and beam system with CLT slabs. So a long journey from fairly simple and obvious buildings to much more complicated and specialist ones, all in the world of timber. And to do that, what we've had to do, we're only 30 people. Our practice doesn't aspire to be hundreds and hundreds of staff. We want to remain experts in what we do and do it very, very well. In order to do that as a small business, what we have to do is reach out and collaborate, do things like we're doing here today to try and teach some of the engineers and architects of the future or the present as well about the things that we do, but also to collaborate with world-leading institutes on research propositions and on ways to push forward the amount of knowledge in the industry. And I can't express enough how much that collegiate approach is important in this process. If what you're trying to ask people to do is something that you really think they should, but that they don't necessarily want to, you don't do that by shouting and by telling people they're wrong. You do that through debate and through evidence and through careful working together. We also work very closely with policymakers, and this was touched on a little bit, I think, this morning, but one of the main reasons that we have a context for building in mass timber in the UK, and we now have nearly 500 CLT buildings in the UK, is because we've all been able to start to have productive conversations with policymakers. We as a business go out, I work as a design reviewer in a local municipality to help them decide whether planning applications are of the appropriate quality. We work with national government organisations like Kibe, who go out and do that on a national scale, and we also lobby hard to change the policy that decides what sorts of buildings we have in order to make this meaningful change to think about embodied carbon as well as carbon that's emitted in use. And you can see some of the sorts of documents and bodies that we contribute to on this screen. So I've touched on it already. I know not everybody here is necessarily a specialist either in architecture or in sustainable design. Very simply, cross-laminated timber is a solid wood panel, typically between 80 millimeters and say 300 millimeters in thickness. It is a different thing to timber frame. These are not small individual elements formed together to make a panel. These are planks of wood laid in sequence. The zigzag you can see here is what we call a finger joint, so you make an endless run of an individual plank. They're put next to each other, and the next layer is rotated through 90 degrees, so that's the cross in the cross-laminated timber. And they are put through either a vacuum or a hydraulic press with a very small amount of glue and bonded together in big panels. So what we've got is something solid, dense, strong, that spans in two directions. Technically speaking, although I'm not an engineer, so I won't profess to give you any numbers, we have a product that's comparable with steel in terms of its strength, suffers slightly more in terms of its vibration characteristics, so we end up with thicker elements in places, but also a material that's incredibly light. And so what you can see on the right of the image is a building in progress, large panels being quickly brought from the factory where they're cut to shape, usually in Austria when they're made in Europe, and brought to the building site and put together quickly, cleanly, and accurately. So why did we get interested in this? Well, one of the key things in the UK is that we have a chronic shortage of housing. So not only are we doing lots and lots of building, which is causing lots and lots of carbon to be emitted, but also we're not doing enough of it, so we're going to be doing some more. And our outlook was to say, well, hold on, if we need an extra 200,000 homes a year on top of what we build today, if we continue to do that in the way we always have, that's essentially the same as putting an extra 2 million cars on the road in terms of the amount of carbon we're emitting in the atmosphere. So while we're building a whole set of government policy to reduce emissions from cars, make them more efficient, provide public transport, take them off the road, it seems completely ridiculous to us that we would allow other parts of policy to do the exact opposite. We must have more houses, therefore we must emit more carbon. That seemed counterintuitive to us. So we were very keen to think about what components of the construction industry were at fault for that. And what we found was that the prime candidates were cement, clay, concrete products, steel as well, those that take a lot of energy to take out of the ground, to make into something else, and actually a heck of a lot of energy to get rid of again in the future. So the principle for us was to say, well, hold on, not only should we be omitting those, we should be replacing them with something better. The obvious answer to us was to start to work with timber. So not only are we taking materials out of buildings that are causing a great deal of energy to be used and carbon emitted, what we're putting in its place is a product which actually actively takes carbon out of the atmosphere during the key 30 years of its growth cycle. So what we're doing is taking that carbon, we're locking it away in the building for the life cycle of that building, which we call a process we call sequestration or sequestering the carbon. And this to us seemed an absolute no-brainer. What we have in Europe is a continent which is almost entirely managed in terms of its forestry. There are almost no wild forests. We have a decline in the use of timber for all kinds of other purposes, not least paper, newsprint. So we had all these businesses trying to manage their forests effectively and nowhere for them to go, meaning that trees remained up beyond their useful cycle in terms of absorbing carbon at a high rate, and also became essentially a fire risk standing across Europe if they weren't cut down and used. So to us, there was very little wrong with this idea of replacing concrete and steel with timber in buildings, but all we had to do was convince everybody else that we weren't being really stupid. Similarly, we were very keen on this process because it is almost a zero waste process in itself. So very little that goes through one of these CLT factories goes to waste. Firstly, the majority of the suppliers in Austria are family businesses. They own their entire supply chain, all the way from a tree in a forest to what they're traditionally sent out as what we call dimensionally stable products like softwood, cut planks or fence posts or all those sorts of things. But in order to have a good and efficient business, they had always invested in circular processes. So their offcuts go to bark and wood chips for flooring in playgrounds, or they go to biomass fuel to heat their own factories. And those principles are applied precisely to the process that they now use to make and press CLT panels and form them to the right size for building sites. So even within their own processes, what we're looking at is something that has a very, very light touch on the environment and a very, very light touch in terms of the waste that it produces. The other things we like that I'll touch on, I guess, a bit in terms of the UK context in a moment is also the fact that what we're doing is we're putting these processes into a factory. What that means is that we're producing things that are much more accurate dimensionally, that are much more high quality. Every time we make a timber frame in the traditional way, we attach hundreds of small components together. And if we do that in the wind and the rain on a building site, every time we join two things together is an opportunity to make a mistake, to have a poor quality building, to lose air, to lose heat, all those great things we were talking about this morning in terms of the passive principles of construction. If we make our materials out of 3 meter wide, 6 meter long, solid timber panels pressed in a factory and cut to 2 millimeter tolerance on a laser guided CNC machine, we've vastly reduced the potential for error and for the reduction in quality. And there are some other great benefits which I think are probably best touched on in a second. But actually, the next phase of what we're working on in the UK is to go beyond simply making panels in the factory, but to do something which I know is familiar to the Japanese market, but very much less so in Europe, which is to make whole modular housing blocks, to fit kitchens, to fit plasterboard, to do all those things in the factory, but to do it with CLT. Because I think the failure that we've made in trying to mechanize the construction industry is that we've been trying to design machines that replicate processes which are designed for humans. So we're trying to make robots that manipulate thousands of little bricks that are the shape and weight that's appropriate for a human hand. It seems absolutely crazy when what we should be doing is feeding machines through robots that already exist. Large format products that machines can handle more easily, that can be cut to very tight tolerances. So we're now at the vanguard working with two major suppliers in the UK of building CNC cut modular volumetric housing systems. So why is this important stuff? Well, we've touched on it a little bit, but I think it's really interesting, I guess, well, interesting for me, you can disagree, to understand what that means in the context of the UK market. Why is the UK a place where 500 CLT homes have been built and maybe not, even in markets in Austria and Germany where a lot of the timber comes from? Well, firstly, in the UK we aren't building enough homes, but also because we're not building enough homes, homes are too expensive. Now, I won't try and do the maths in my head from pounds sterling to yen, but on the right we have a home which is considered affordable. It's for shared ownership. This means that a young person can buy a quarter of the home and pay rent on the remaining 3/4. The whole value of that home is £1 million. For a two-bedroom flat. Now, that is not by anybody's measure affordable. So this is the situation that we need to address in the UK. There are lots of reasons for that, but those reasons are also connected to the way that we either do or do not innovate. So actually, we have lots and lots of planning consents. We have permission to build all these homes. We have planning consents for nearly for 615,000 homes, but they're held by 7 really big companies. And those big companies only actually started 150,000 homes in that same year, and they finished 66,000. So what we have is this weird situation where these big companies own the housing stock, the market, but they're disincentivized. They have no good reason to build all these homes, because all they would then do is devalue their £1 million homes. Bit of a crazy situation. So we have some opportunities to challenge that. That challenge should come from smaller businesses that innovate and build things in different ways, do the things that we suggest. But they've had a challenge in terms of access to sites. So what we're trying to do in the UK is liberate sites, reduce that financial burden, allow people to make different decisions to the ones they always have, that perpetuate the same situation. And one of the ways we're doing that is bringing the statutory landowners into play. So for example, Network Rail, who own our national railway infrastructure, they own around 7,000 individual development sites that are worth £1 billion, and they're being encouraged by the state to release those to open up this space for innovation. We also have a challenge that even if we do build these 200,000 homes a year extra that we need, the problem is we don't really have anyone to build them. And there are two reasons why we don't have people to build them. Firstly, we've made construction seem like an undesirable industry, so people are leaving it and people are not joining it to replace them. It's perceived of as a dirty, messy, dangerous place to work. It's also perceived of as a place where stupid people work. In 1997, famously, we elected a progressive prime minister who said, education, education, education. That means that 50% of our 16-year-olds that leave the high school part of their education go to university. Well, the byproduct of that is that those 50% of people feel like they've failed, if they have done a university degree and then find themselves laying bricks or mixing concrete. So we have a real image problem with being in the construction sector. And then, of course, on the right, I try not to use the B word as often as I can. I'm not sure how well that will translate, but nonetheless, we have to worry about Brexit. The UK is leaving the EU. More than 50% of our skilled workforce in London is from the EU. We don't know if after March they will be allowed to continue to work in London. So we have a challenge. So what that means for us is that way that we have always built stuff, that small things lifted up, placed by individual humans, we can't do that the same way anymore, because not only do we not have enough people to do it, they don't want to, even if we were to incentivize them. So what are the solutions? Well, we think, unsurprisingly, given the way we started the lecture, that we think we should be building in wood and that we should be building off-site. We should be building in places that are comfortable to work. We should be building in safe, clean factory environments. We should be building in a way that means people don't have to get up at 5 o'clock in the morning to travel to the building sites to do their work. They should be able to stay with their children. They should be able to have regular, secure employment. And we should be building better, quicker, lighter, all those things that we're offered by building in timber. And so there are pieces of policy that are starting to support some of this. In the UK, you can go and read the bits of policy that we have. There have been government reviews to try and support this kind of policy change. London is leading the way. You can go and look at any of these documents. They're free to download online. Interestingly, a part of our work is also to help internationally with this. Unfortunately, it was too late to include in my presentation here, but in the last week, we've just released online a study that we were commissioned to do by a North American lobbying agency, which provides case studies and data from 100 CLT buildings in the UK. Perhaps I'll ask Eckhard to send a link if any of you are interested to download that. So we have this prominent role in gathering the evidence and providing to all the stakeholders that they should change the way that they approach these processes. But something that we're asked a lot is, well, okay, if we're going to make it all in a factory and it's going to be done in Austria and brought to site, if we're going to go even further and make individual small boxes, can that process be flexible? Can it be high quality architecture? Can it do all the things that we normally want it to do? And similarly, we're asked that by developers who say to us, well, hey, you know, last week I was selling beautiful little white boxes and I'm used to that and I know how much they should be sold for and how much they should cost me to build. So am I now going to have to sell 100 sawdust on the day that I open my new building? I don't understand. So one of the big questions we had to answer was, can it be flexible? Can it be something that people recognize? Can it be high-quality architecture? But fortunately, that was precisely the reason that we became involved in building in timber. We wanted to build in an incredibly sustainable way, but we didn't feel that we had to walk around, looking like hippies from a beach, with some kind of investment in a lifestyle. What we want to do is incredibly beautiful, high-quality architecture. So what we also have to acknowledge is that nobody wants this. But by doing this, we can provide something rather different. So to me, off-site manufacture, and particularly in the world of timber, is a spectrum of solutions. I think people can possibly look a little silly when they stand up and talk and say, this is the one solution, this is the only way that we can achieve all of our aims. For starters, we don't think that this is the end of concrete. You've heard me talk already about the need in the UK for an extra 200,000 homes every year. Even if we just built those in timber, we'd have a massive impact on the amount of carbon that we're emitting into the atmosphere. And so similarly, I also don't think that CLT and CLT alone and building in volumetric factories is the only way to solve all those other problems we have in the UK construction industry. By far the best approach, and we've heard this again this morning in terms of our approach to energy in use, is to appraise each individual site and choose the correct packet or package of solutions to address that individual problem. So here's an example of a volumetric building that we're working on at the moment. This goes on site at the end of the year. It's for a housing association, so this is affordable housing for people who don't have a great deal of money. This company is called New Living, or Swan is their parent company, and they have invested in building a factory to build all the homes that they'll provide for their affordable tenants for the next 10 years. They think they'll pay off that factory, by the way, in terms of quicker construction, in terms of better construction without failures and needs to be remediated, in about 5 years. We have just designed their first multi-storey products. They're already building individual two-storey homes. This will be the tallest volumetric modular building in timber in the UK. And we've designed the system from scratch, all the connections, we're codifying that, we're turning that into a document for other architects to use to move on with. And it's simply about making a good set of decisions. So what we have here is quite a regular building, a building with lots of right angles. But I think by making careful decisions and manipulating the mass, designing from the very first principles to have a modular building, so that all of the architectural changes in composition come from big moves in plan or big moves in cross-section. We're not pushing things in and out ever so slightly. We're choosing things that work with the innate characteristics of the material. We're choosing materials that are light and that hang from the timber. It's very silly to make a lightweight building and to put heavyweight things on the outside of it, but then you'll see that we've done that too, just to keep ourselves entertained. But also designing ways that we aren't constrained by the size of the back of a lorry. So you'll see the diagram at the bottom right, which explains how we make homes that are larger than that individual box. So for this site, for this client who wanted to build their own factory, who wanted to invest in a process, volumetric modular was exactly the right answer. Affordable homes, repetitive, but high quality and safe. For a different kind of project on a very dense urban site in East London, what we need is something that can accept the idea that every home is different in plan, so that we can squeeze the most homes onto that site to get the best value out of that in central London. Here, interestingly, by building out of timber, we were able to put 2 whole extra stories on the building. You can see on the photo on the right, there's a train line. There are also both an existing train line and a proposed train line that run directly under the building. So the whole 10 stories of that construction at its tallest part are supported on a 900mm thick raft foundation. That doesn't have long piles that go into the ground to support it. It's simply one slab, 900mm thick. We couldn't have done that in concrete and made that site viable. So alongside all these conversations about what are the things we should do, how should we approach sustainability, things that frankly quite a lot of our clients don't really care about, we need alongside that to have conversations to say, but yes, what if we could build this building 20% faster so that you pay the bank 20% less money on the money that you borrowed to build this? What if you can have 25 to 35% more homes on the site? Do you want to work in timber now? And the answer invariably is yes. So when we designed this building, you can see that here we have many fewer right-angle corners. This is not a simply organised building. It's very, very tightly planned. There are some careful architectural devices. You can see on the closed courtyard to the left, we put all the bedrooms to that side, and we put all the living rooms to the outside, so that we put the noise and the balconies away, so we can have a tighter courtyard without people sitting on their balcony gazing into their neighbour's bedroom window. But also we're very careful to provide the maximum number of dual aspect homes that we can, so that we can allow breezes to go through the entire home to cool it in the summer. So the aim here is to have a technology that allows us to continue to be conscientious architects designing high quality buildings that are appropriate for their context. There's no conflict between the idea of building in timber and the idea of high quality architecture that's flexible. Here you can see the building under construction. So in terms of the volume of timber here, this is the largest cross-laminated timber building in the world. It is maybe the tallest panelised timber building, so we have many taller ones. There's one that I know a few of you are aware of in Vancouver that's 18 stories, made from columns and beams with CLT floors. This building is made from CLT panels all the way from the first floor slab, which starts here, which is a concrete deck, everything above there, including the walls that form the stair and lift shaft. Even the stair flights themselves is CLT brought from Austria. It's 121 homes. There's an additional 3,500 square metres of office space in a multi-storey office block in the centre here. Viewed from above, you can see, I guess, the scale. There are 7 separate vertical circulation cores, which I guess helps understand the scale of the building. But here, part of the narrative was for us to demonstrate to our client that they could have it quicker, they could have more, they could make their money, but they could have the product that they were used to selling. So it's a sad thing in many cases, but a lot of our buildings, we don't expose a lot of the timber structure that we create. Whilst that is sad, our aim actually is to do the most building possible in ways that are low in embodied carbon and high in sequestered carbon. So if we can convince a normal developer to produce his normal building from this technology, that is a vast success for us before we start to think about the beauty and qualities of the material. And don't worry Gallery, there's a few of those too. At the bottom left, you can see an image of some of the office space there. When it was completed, the timber surfaces were left exposed. But to the right, you can see just an average everyday home that's exactly the same as all the others in London. And also, we could prove that if you really do want to hang heavy stuff on the outside of our lightweight building, well, you can do that too. So this whole building is clad in bricks. We have a strong affection for bricks in the UK and London specifically. So to be able to prove to our clients that they could have what they wanted, whilst slightly counterintuitive, was a really important thing to be able to achieve. So here are some key statistics. We've talked about how many fewer homes we might have built had we been building in concrete. But also there's lots of benefits for the community too. When you deliver wet materials that need to be kept alive as they move from the plant to the construction site like concrete, firstly you generate lots and lots of journeys. So if you live next door to a building site that's made from concrete, you've constantly got dust and dirt and lorries arriving every half an hour with fresh batches of concrete. Also, once they've finished, all you've got are columns and slabs. Now, for a building this size, to do all the columns and slabs in concrete, we would have required 700 deliveries to site, and noise and clanking and pumping and all that noise. In order to deliver the CLT building, we needed only 111 deliveries. But, by the way, what you get is all the external walls, a large proportion of the internal walls, the shaft that carries the lift and stairs, the staircases themselves, all in that 80% fewer deliveries that we make to site. And all erected by a small team of tradespeople with electric drills, not jackhammers, not pumps, not loud noises. So if we're going to carry on building in dense urban environments, we want to do it quickly, we want to do it quietly, we want to do it in a way that is appropriate to its context. So CLT can really help us with that. In the building structure, there are 2,325 trees worth of timber, give or take. It's a bit of an estimate. But for one of the first questions I ask is, well, okay, but what about all this cutting trees down? Surely that's bad, isn't it? So we worked with Binderholz, who are the company who supplied the CLT to build this project, and they estimated that from the Austrian forest where they grew the timber, that's the equivalent of about 3 hours timber growth. So to build these buildings out of wood is incredibly sustainable in terms of the scope of the industry that we've got now. We're not going to run out of wood. We're not going to stop taking carbon out of the atmosphere. The wood that we're using is the wood that was going to make fence posts and newspaper. It is reasonably low quality wood. It needs to be carefully grown. It needs to be pretty straight, not super knotty. But actually, it's not highly engineered stuff. It's the stuff that we were having problems with burning itself down in the first place. So a third approach, which we're really interested in, is this idea that, well, okay, just because we think CLT is a great idea doesn't mean it fits for every single scenario. And I think what we've got to be open to is the idea that we create hybrid structures. I'll show you a couple more in a second that are, I guess, more obviously hybrid, that work with completely different materials as opposed to just timber. But this is an example of a building where we combined two different timber technologies, and we combined that with the kind of wider world of off-site manufacture. So in the image on the left, what you can see is what we in the UK call a pod bathroom. I'm pretty certain the dormitory I'm staying in over there has a pod bathroom, not an unusual thing to provide. So a bathroom made, fitted out, all the sanitary ware provided in a factory and brought to site. And then in the middle we have a panel system. So this is individual sticks of softwood made into panels, but also with the window and the insulation and all the membranes and things we'd apply to the outside of the building installed already in the factory. That's not a process that's very common in the CLT world. So does that mean then, if we're going to do all these different bits of off-site things, that we have to have square, boring buildings? Well, hopefully you can see emerging on the right something that's not that. But I'll show you in a second, that's the product of a series of very, very careful individual decisions. So this site was on essentially a traffic roundabout. We had to build very, very quickly. We had to do it as quietly as possible. It's student housing, so we had to be finished by the beginning of term, or else there would have been a lot of students sleeping on the streets, which is not anything that I'm sure anybody in this room wants to think about. So what we did was we combined the right technologies for the right jobs. We needed to save space, use the maximum amount of the wall, so the hybrid of timber frame technology with insulation inside it was great for our external walls. CLT is what we used for the walls coloured in yellow and for the floor decks because we know that we can get all our structure, we can deliver it quickly, erect it accurately without stopping the traffic too much. And all those things can be actually really quite flexible so long as we design within constraints. So you can see that there are a variety of different room shapes, there are a variety of different shapes and sizes and holes in walls that are made from CLT. So we're choosing the right products to achieve the right elements of flexibility. Whilst what we've tried to do is make all the pod bathrooms, apart from the wheelchair accessible one, identical. So in the factory where we're buying a repetitive product, we're not looking for that. So what it shows is that by mixing different materials and different processes, we can get the right sort of things that we need for any individual project. Here, for example, it was really effective to be able to cut out all the routes for cables and for sockets in the factory to help us with that super quick construction program, because in a student project, we're not looking to change or reconfigure that in the future, whereas we might not have made those decisions for homes that we were going to sell. So every time we're approaching a project in a unique way with the palette of tools that we have to design in a low carbon, efficient, nice place to work kind of way, and compiling them to make the buildings that we want. Here you can see those external wall panels brought to site with membranes on, lifted and placed on top of each other, and what we've got inside is then an environment where we can work the day after. When we make concrete buildings, it takes 28 days for a concrete slab to become incredibly hard and ready to work on, ready to load your building materials onto even. So whilst you can accelerate that slightly, every time you pour a floor of concrete, you have to wait before you can start building. If you build in timber and timber hybrid technologies, the day after you put the walls and floors up, you can be putting plasterboarding, you can be putting pipework, you can be finishing that building, all of which contributes to a much quicker process, as well as all those other benefits in terms of sustainability. And here you can see, you know, as a practice, we don't have a phobia against the normal things we make buildings out of. If they're the right choice, that's what we do. So in between all these great off-site timber technologies, all those strange corners, all those odd junctions, those are made out of the things that in the UK we make the majority of our buildings out of, which is lightweight metal stud work.